Hi, welcome to this video. It is probably not going to be an extremely short video, but I'll try to keep it as simple as possible. What we're going to talk about is using Alteryx to manage your data. Situation has occurred everywhere that I've worked with data, especially when you're dealing with individual data analysts responsible for finding their own data and reporting against that data, is you end up finding a really nice data set. You generate a nice looking report or dashboard for it. Everybody goes, that's great, but you only have a month's worth of data in it. We would like to see a year's worth of data, and we like it updated every week. So you go to the data warehouse team and you say, hey, here's a neat set of data. Why don't you productionalize it? And their answer is, yeah, we'll do that within the next year or two. We're really busy right now. So suddenly it's your responsibility to manage that data. Now, you should always try to keep your data management as simple as possible. And what I mean by that is that your first look at your data may be to have pulled a month or two's worth of data down, manipulated it, prepared it, and then reported on it. If you can continue to manage your data in a pull all the data that I need and generate a data store and report from that data store, you can continue to use that initial Alteryx workflow. However, when it gets to be quite time consuming or possibly not even performance management of pulling all of that data from the source system and then processing all the data through your workflow, you will want to find a different way of doing it. So we want to talk about ways that you can manage that data store as far as inserting, updating, deleting the records in it on an ongoing basis, whether that be weekly, monthly, or quarterly. So you have to look at what is your data. So I've put together this quick little quadrant that shows the amount of data change in the bottom across the amount of data that you have going up. And it gets more complex as you move into the large change, large data. There's also a point where you don't even have to worry about this again, because if you can just bring a full set of data in and load that full set of data in a very timely manner, you don't need to worry about actually managing that data other than doing a trunc and load every time. But if you can't do that and you have to actually look at dealing with changes, you have to look first at how much data do you have in your data store on an ongoing basis. And you notice that I put two little breakpoints here with question marks because there's really not a firm value or size to deal with this. A lot of that depends upon how fast your computer is, how fast your interaction with the network and the RDBMS is. Part of this has to do with how patient you are. I had someone that was running a full data load and it was taking it 2 hours to run, and I said, well, I can make that faster for you. And they said, why? I just run it in the background in the morning and it doesn't pose a problem to me. So that's sort of where this question mark comes in. Now, some studies that I've done and research through performance that I've done utilizing your standard networks and business analysts computers supplied by the organization, I've put this line, both of these lines going either way, at about 5 million records. That's a lot of records and a lot of data. So you don't really have to worry about coming out of this square until you get over 5 million records either in the change set or in the data store itself. Now, as you get up into this, where do you come out of from the small data to large data? Again, 5 million records. That number is slidable because if you're looking at using your computer from home, you're going through your wireless and your VPN, you don't have that very high performance of a computer. However, if you're using an Alteryx server that's actually a Unix box that's dedicated to running Unix workflows, well, suddenly your performance can go from 5 million records in a reasonable period of time upwards of about 20 million records in a reasonable period of time. So then this bar changes significantly. So you need to look at your environment, figure out where you're going. Now, what we want to talk about is how Alteryx satisfies two of the three very important pieces of being a good software. One is performance. How is it performing within any set of data? Two is how extensible it is, which means how is it subjected to change? And the third is how scalable it is. In other words, as you put more data into your workflow, how does that alter the performance? Well, Alteryx really deals with data as flowing, which means that your data comes into your workflow and flows along your workflow like it would in a stream. It can split, it can merge, you can do different things with different pieces of the data, but essentially the data flows all the way through your workflow rather than backing up at some place. A SQL query tends to gather all the data and then process all the data once it's gathered it. In Alteryx, you actually might get a row of data that flows from the beginning to the end of your workflow before data has actually all fully arrived at the beginning of your workflow. This is the beauty of Alteryx that gives you the performance that you can see, as well as gives you the scalability so you can increase it by putting data. How does it do that? Well, it's built into the design of the individual widgets that are executing. If you think of them as gatekeepers, such as you would have in a canal, and that is where the data comes into your widget, it moves into the processing area of the widget, and then it moves out and continues on its flow. And what that means is that the data simply continues to pass through that widget as it appears. Sometimes the widget might have to hold some of the data, such as if you're doing a multi-row formula, but then as it finishes each individual piece of work, it'll go ahead and continue to release it going through. So therefore, the more data you put into this, it doesn't back up and bottle this. It just simply means more data has to pass through the existing widget. This gives you the scalability that you need. And finally, the question always becomes, how do you get your data? Always look at where your data is coming from, how you're using it, and we're going to look at two different ways that we would get the data as far as how to maintain that data. It's always nice if the source system sends you data, but that's not always the case. You have to go find it yourself, and that includes changes sometimes. And finally, the thing to keep in mind is that Alteryx does not have a delete data widget. So if you have data in your data store that needs to go away, you have to take and go through some sort of by the side methodologies to get that data out of your database. And so we'll look at all of this in a couple of workflows where we're dealing with a couple of simple data stores. We'll be pretending it's big in some of these and small in the others. Basically, I created a customer table. Everybody's familiar with that. It has a customer ID, a customer name, a city name, state code, etc. And this allows us to do some very minor manipulations of it. If we look at this table, you'll see also that I have defined a primary key as the customer ID. This is very important as we get into one of the specific update methodologies that we'll be employing. For this one, it must have a primary key. And so then we have some data changes going on, and I've just, for the convenience purposes, stored my change data in a YXDB or an Alteryx database table. One reason I did that is because then if I simply click on this table, it's very easy to read also, by the way, but also you can look at it by double clicking on a YXDB and it brings up a little spreadsheet kind of view of this data. You can't modify the data, but it really lets you take a look at the data that's there. Makes it nice to have in that kind of format. So I went ahead and moved my update records into a YXDB before I started this presentation so that it's easy to see and easy to use. So in our first example, we're going to look at how to deal with a small set of data. Since the data is small, it means that I can use all this data, or do the entire workflow within my Alteryx environment without going to any extraneous methodologies in order to get the database to help us out. So let's go ahead and look at our two data sets. For convenience, just going to cut and paste them into here. So here's our update file. Drop a select next to it. We can see what it is. Here's our set of updates. You notice that it has an action code. This action code will tell me if the data is an insert, an update, or a delete. So it's been pre-marked for me. This is sometimes called a log file. And then, of course, I have my source table out on the database. Hit refresh very quickly, and you can see that it is here as well. Again, it is a very small data set. Drop a select on here as well, just so we can see what it looks like. Everything is cool. So in determining which records I want out of these two sets of data, we're going to drag in the join widget. I like to always remind business analysts that I work with that when you're dealing with the Alteryx join widget, you don't want to see it as a database join, but this is simply a way of merging data together and figuring out how it fits. Because on the output of the join widget, we have the left join, which is records at the top that do not have a match on the bottom. We have the right, which is the records on the bottom that do not have a match on top. And then we have the ones that actually match in the middle. So when we do this, this will be showing us that on the left side, we'll drop a select in here on the left side. Let's go ahead and run this very quickly just so that we can see data as we go into each of our widgets. As you notice that join has already been done. So on the left side, I have what I like to call my inserts. These are records that occur in the update file, but not are already in the database. So those are records that I'll be inserting. And you can see I have approximately 28 of these that I am inserting. Down the bottom, we have a set of records. And the records at the bottom are records that are unchanged. These are records that do not exist in either the update or the delete, so those records just want to pass forward as well. Now, as I work on this data set up here, one thing I do need to remember to do is go ahead, and I do not need the action code anymore because it's already been identified. Now, in the middle of join, we have two things. So if you look at this data, we have the updates and the deletes. So any update, we want to bring that update record through. And if it's a delete, we want to leave it behind. So it's very easy to process deletes from this methodology. And it's simply here, I will put a filter. And within that filter, configure it to say that action code equals U for an update. And those are the records that I want to move forward. The ones that are false, so again, if I run this, those that are false are the deletes. Those records will simply be left out of this process. I also want to go here and make sure that I only select the data that I need, which is I do not need the right side, I need the left side because that is the new data. So here are the inserted records. Here are the updated records. And here are the unchanged records. Bringing them all together to go back into my database. All I want to do is drop in a union. Drag all these in so I have my inserts, my updates, and my unchanged records. My deletes down here in the false are left behind. And then finally, the only thing I need to do is to go ahead and drop in. In this case, I'll just insert to save me some typing. I'll drop in my output widget. I will go to the MySQL database. I want to do a delete and append. So in my output options, it's delete and append. It will delete the existing data that's in that table and then simply insert all the new data in. So essentially what I'm doing is taking my entire data set, bringing it down into my local Alteryx workflow, figuring out what I want from here, and putting it back up into the database. If I have any additional processing that I need to do this data, I can either do it on the data that's coming in, which would be in this area, or perform it here afterwards. Recommend that this is where you want to do your data because this is the data that would need to be manipulated. This data has already been manipulated and the deletes will be left out. Let's go ahead and run this data through. Runs very quickly. We can look in the log here and see that 48 records came in from the database. We had 47 update records. And we had a split here saying of what came through. So if we look here, we see that we had 29 original records. We had 5 deletes, 14 updates, and 28 inserts. You do the math. And we end up with 71 records going into our database. So how do we need to alter this workflow in order to deal with a large data set in our RDBMS? Because we cannot or don't want to wait for all that data to be fed into our Alteryx workflow. So we'll start out with our update file. I'll paste in a previous version of this. So here's our data set. Let's run it. And you can see that in the output data we have updates, inserts, and deletes. So what we're going to do first of all is to separate out our deletes, and we'll deal with them second, because remember, Alteryx doesn't have a clean way of dealing with deletes. But it does have an alternate way to deal with updates. So let's go ahead on action code. If it equals a D for a delete, change our comment to say split out deletes. Let's put a select on the end of each of these so we can see what the data looks like. Take a quick run, and you can see our 5 deletes are up here. Our 42 updates and inserts are down here. Going into processing this data, we'll take off the action code. And very simply, what we want to do is in our output data, choose our MySQL database. Name of our table is, sure wish this could be a lookup, make our life a little bit easier, but customer is a simple name. So once I fix the quota that I don't like, here in the output options, if we drop them down, we say update, insert if new. This is known as an upsert in the technical world. So Alteryx will allow you to do this. However, for this to be accomplished, Alteryx has to find a primary key in your target database table. A lot of DBAs do not like to add primary key indexes into your data warehouse because they say it slows it down during inserts. There's ways to get around that, but at the end of the day, you must have a primary key defined. As you can see here on the customer table, I do have a primary key defined on customer ID. This is what the create table looks like, where I actually identify the primary key. In our SQL class, we talked about how to do and alter and add primary keys, as well as do that within your workflow or do it within the database. If you need additional help, seek it out with your DBA or drop me a note and we can walk through some of those processes. So if we run this very quickly, as it accesses our database, again, my SQL database that I have is just a tiny bit slow, but that has to do with its configuration rather than its overall workflow issues. So if we look in our log file, we will see that it actually split this out and said that there were 28 new records inserted and 14 records updated. So it actually does the insert because it can find the primary key. But what about these deletes? Since there is no option for deleting it, we're going to pull a little trick in here. Oh, not necessarily a trick, but just a methodology that I've employed many times in order to get this to process. So what I'm going to do is to create a table that is my delete table. I'm going to paste it in here just to make this go a little bit faster. So here is my delete table. So I'm going to take these deletes and put them into a delete table. It's actually called customer delete temp. It will overwrite the table, it will drop the table and create a new one. The quick and easy way of getting this done. This works very well so that if the table is empty, it will, even if the workflow has no deletes in it, the table will still be dropped. And up here, all I want to do is have the customer ID and the customer name. All I really need is the customer ID, but the customer name makes it sort of nice to see. So when I run this now, it will create this table with deletes. And before we actually do that, we'll go ahead and in the background, put my data back the way it was. So this will run through the same way. Have another workflow that actually creates this table, customer table, with the primary key, by the way. So as that's being completed, we can go ahead and run this workflow. So as you can see, the 5 delete records were separated out. It wrote 5 to the delete table. It's currently doing the upsert for this database. And again, the processing takes a little bit of time, but not very long. And so therefore you can see that if we go into our database, there will be 5 records. How do we want to do this delete? Well, this is where you again have to understand some of the features of Alteryx as well as within the database. And we're going to pull a short little trick that I learned to do actually before even I used Alteryx. This is a great way within the database to do this work directly as well, using a stored procedure language. But here in my create table statement, you have a post create and a pre-create SQL statement. And while if you look at some of my other videos, we use the post create to create primary keys, we're going to use this post create so that after these records are written and updated, we will go ahead and then run a delete statement to delete the records in the customer table that match the records in the delete table. And what that looks like is very simply what's called a join delete. Now, depending upon your RDBMS that you are using, your join delete might have a slightly different structure. This is the structure for the delete statement within MySQL. I'll be deleting from the alias table C, which is customer, where that customer table is joined to the delete temp table and matching on customer ID. So only the records that are returned from this join will actually be deleted. We can execute this just to verify that it works. You can see down here, it shows me that 5 records were actually deleted. So we know that this works. What we'll want to do is take the same piece of SQL and put it into the post create SQL statement. Click on the 3 ellipses, paste in the SQL that I know works. You notice it's not going to do any validation of this. It's going to wait and do that when it actually tries to run it. So you need to be careful, do some testing, have a small test set to run with. We'll click on OK. And just to get things started again, we will go ahead and run my create while we talk about something else. So if you look at this workflow, I have to actually create the data in this table before I do the upsert into my customer table. And so I want to stage this being the first workflow that gets completed, this being the second workflow that gets completed. If you've run into some problems where you're trying to do parallel processing that has the order to run in, you will find that Alteryx picks its best guess as to which order to run your widgets in. So there's a chance that it'll start inserting these records or complete inserting these records before it creates this table. So we want to stage this one versus the other. If you don't want to create 2 jobs to this, you will want to try to use another feature. If you go into Developer, there is a block until done widget. But the only problem with the block until done widget that Alteryx has is that there's one stream of data that flows into it, and then it actually then does the work from those. Well, in this case, we have two streams of data. So this block for done, while we could use it, is a bit tough to use it. And in this situation, Alteryx recommends that you do is to play some games and use some macros with triggers on them to get them to do one at a time. Well, we're not actually going to do that because that's a bit of an extension of work. And this also gives me an opportunity to point something else out as well. There is an organization that created a whole set of macros called the crew macros. These macros, some have been validated quite extensively by Alteryx themselves. Others have all been validated by the user community. So I use a number of the macros in some of my other work that I do. And for this case, they actually have a block macro that will do the work of two streams in, one stream out. And it's called a parallel block. If you're looking for these macros, I will post a couple of URLs into the comments for this video. But pretty much what you will see is that the first link that I send you is this one, which shows the crew macro support that talks from the Alteryx knowledge base standpoint of what crew is and how to use it with people that have commented and used them. It also has a link to get to the macro package that you can install with instructions. I'm going to include that link up here as well. And so this is Chaos Reigns Within, which has these macros. Again, caution, test them, make sure they do what you want them to do before you try to put into a production workflow. Has instructions for implementing them so that you can then select them and have them appear in your category ribbon. But again, what we want to use on this is the parallel block until done. Very simple widget. Whoop. Here's the parallel block until done. It has two inputs. One is the first stream that you'll be running, and the second one is the second workflow that you'll be running, and it has two outcoming workflows, which is then staging it. So what we're doing, no configurations required. If you click on this, it says it has no configurations. So what will happen because of this crew macro is that this stream will be completed first before this stream runs second. So we'll make sure that we assure ourselves that the create table with the deletes is executed before the post SQL statement. So now we've done that, we can run this test. And you can see that we got 100% done up here before the second one even started. So our 5 records have already been written into the MySQL database. We are now doing the upsert for the update records. 28 inserted and 14 updated. And you see right here in well is the executing PostSQL. This delete statement was run. So we can now go back into the MySQL workbench. Getting rid of this, say select star from customer, order by customer ID. Oops, too many froms. And as you can see, we are missing a few records in here. 10 and 11 are missing because they were actually deleted. So we know that this now works. So here's some new things to be concerned about, which is using the PostSQL statement and using a crew macro to make sure that your deletes get written to a table before the PostSQL statement. So let's look at the second type of change file you might get. Actually, in most cases, this is the type of file that you would pull yourself as opposed to receive, and it's what I call the Delta file. This is where you simply get a file or do a query to pull all the records that changed since the last time that you ran the update. So in this case, you do not get the really nice insert, update, or delete. All you know is that these records have changed since the last time we ran the process. Well, this actually turns out to be a simpler workflow to build, especially when you can bring all the data down into your Alteryx workstream. So if we bring all our data in, so now we have all of the changes and all of the original. Run this quickly, make sure everything works. We really don't have to do anything here within the selects because my data is not being stored in a flat file, but again, this is where you want to change your data types to match what's coming in from your database. So all we want to do here now is to simply drag in our join, because our join will weed out the differences for us. We have the left and right side. We join this on customer ID. And we'll go ahead and drop in 3 selects. Top select is on the left. And when we look at it from an English standpoint, the left are the records that don't match anything on the right, which is top to bottom. And they would be records that need to be inserted. Drop a select in the middle on the J, which is join. These are the records that represent our updates. And here what we want to do is configure it so that we don't have anything from the right side, because the left side is the new record. And the right side is the old record. And then finally, we'll drop one more down here on the R. And the R's represent the records that are unchanged because they don't have a matched record coming in that represents a change. And that is all of our original data. Very simply, all we do now is union these 3 together. 1, 2, 3. We add our output widget. And again, this is a delete data and append because we can throw everything away that we had and put in all the new data. Run this through quickly. "48 records came in. 14, 28, and 34 are the nomenclatures for what was insert, update, and unchanged. And then finally, all of that data will be written back out to the MySQL database. It gives us the 76 records because we didn't have any deletes. In this methodology, since we cannot see a delete in the database, we'll have to have a different way of identifying and processing those deletes. But this is a very quick, simple, straightforward workflow. If all that you have are the change records, you use the join widget to identify how they match up with insert, update, or unchanged. Union it back together again, and there's your new data set. So in our next workflow, we'll look at the situation where you have a Delta file and you have a large data set, so you can't bring it down. This workflow becomes so simple that you wonder why I didn't use it for the small data, and the answer is I have fun doing joins. But you could use this exact same workflow for the small data set as well. And in this workflow, it simply reads in our Delta file, make sure that everything lines up and looks good, and then we do an upsert, the update insert if new. Since I copied this in, we need to make sure we get rid of this delete that's in here. What happens when you cut and paste? So again, we simply connect to our ODBC customer table. It has a primary key identified on it. We can do the update insert in if new, which is considered the upsert, and off it goes. Running this. Go ahead and process our 42 changed records. And we'll let the output widgets sort them between the updates and the inserts, so we don't have to create parts of the workflow that will do it for us. Very simple, easy to program, but again, it requires the primary key on your database table. In our final two workflows of this video, we will talk about handling deletes. Deletes present two problems from a data warehousing and from a reporting standpoint. If the application database can't tell you what's been deleted, it is extremely difficult to figure it out from within the data warehouse or your own personal reporting database structures. The second thing to consider is, do you actually want to delete records? Because from a reporting standpoint, if you're reporting history, you need those records from a historical standpoint. So keep in mind those two things before you decide to head into deleting data, as far as how and why. But taking the assumption that you do indeed want to delete your data, we'll look at the two examples, both from a large table standpoint and from a small table standpoint. From the small table standpoint, we're going to do all of this work within our Alteryx workflow. So we've brought in our deleted records and our target database tables. Run this workflow that I pasted in very quickly. You see here are our 5 delete records that we've been dealing with. And then here is the source records after the updates that we applied in the previous set of videos. So we'll simply drag in our join widget. Again, this is not a database join, this is an Alteryx join, so it actually brings your workflow in. We tell it how to connect. And what this tells us in this situation is anything in the left-hand side. Let's run this very quickly because it's fast. The left or top output connector will show us any records from the delete pool that are not actually in the data warehouse or in our target data store. The J, or the middle, the join, shows us which records actually match that need to be deleted. And the bottom, or R, shows us all the records that are passed strictly through this, those that are not matched by a delete. So if you're thinking ahead, you'll understand where we're going with this. Drop a select on here just to verify the data types. Always a good idea, what I like to do. And then what we'll end up doing is we need an output widget. Simplify this process, I'll cut and paste in the one that we've actually been using for a number of these small. And that is, we simply go into our customer table and we do delete data and append, and then this will result in the 71 records that we want to keep as part of this final process. And you can see how the data is appearing along the way as it's being processed. As we watch the log go, we see that here's our 5 delete records on our 71 keep records. And now we're simply waiting for the MySQL database to accept those 71 records and to put them into the database. And we see that we successfully completed this. And finally, let's deal with deleting records where we have a large target table that we don't want to bring into our Alteryx workflow. This process starts out with our delete records. And then all we need to do is a 2-step configuration of the output widget. Just to walk you through this very quickly, where we're writing it out is into our customer temp delete table. Again, this is not validated. As I look back at my notes, I realize that this is customer delete temp, just to keep it standard. What we want to do here is not quoted. And also, rather than create a new table, we want to drop table. So we'll create a new table each time, not worrying about what's there, because all this is ever going to include is the records that we directly want to delete. We come back to the delete statement that we've used in the previous examples that's been validated. We cut out that good piece of SQL. We put it in the post create SQL statement. We can do this all in one widget because there's only one output operation and we have no concerns about order and nothing else that we need to do. Looks good. We like it. We can now run it. Following along in the log file, you'll see that our 5 records come in. They're written to our table. Once they're written to the table, the post SQL statement was executed. It doesn't give us a validation of how many records were deleted. That's all inside of the database. So to validate that, we can bring up our SQL workbench, execute our query, and we can see, if we remember right, 10 and 11 have indeed been deleted. So with that, we've wrapped up this video. We've created a number of workflows that deals with insert, updates, and deletes from different sources, as well as with large and small target table sizes. If you have any questions, make sure to subscribe so you can see future videos. Drop me a comment with your questions. If you have some additional information that you need, put that in the comments as well. And I'll be able to create some new workflows to help address any of the issues that you're running into on a daily basis. Have a great day. Thanks.